Hello everyone, welcome to the guided notes on graphing the sine function f of x equals sine x. We're going to start by graphing a table of values, or filling in a table of values, and then graphing the sine function from there. All right, so I would like to, let's start here in the middle of the table. And we're thinking the whole time about this unit circle that's in our mind's eye as we fill in these values. All right, there's our unit circle, just as a reference. All right, so the sine at 0 degrees, that's going to be the y value at 0 degrees, that is 0. The sine at pi over 2, remember these points are 1, 0, 0, 1, negative 1, 0, and 0, comma, negative 1. Okay, so we're going in intervals of pi over 2 around the circle. So the sine at pi over 2 is 1, the sine at pi is 0, the sine at 3 pi over 2 is negative 1, and the sine at 2 pi is 0. Okay, so here's what I'm looking at. Plotting the points 0, 0, plotting the points pi over 2, comma 1, plotting pi, 0, plotting 3 pi over 2, negative 1, and plotting 2 pi. What you'll notice here is that I'm using radian values for the x-axis, and I'm using integer values for the y-axis. Okay, so as it says in the note, it's only important to graph the critical points accurately, and after that, you can just sketch by connecting the dots, right? It doesn't have to be perfect, but by having accurate values along the x-axis, and then critical points that are accurate. There's the graph of the sine of x. Now let's fill this in. If I go a rotation of negative pi over 2, that's down here at 3 pi over 2. The sine is negative 1. At negative pi, so I'm just working my way back around the circle, it's 0. At negative 3 pi over 2, the sine is 1. And then the sine at negative 2 pi is back to 0. So what I'm looking at is a function that looks like this. This would be negative pi over 2, this would be negative pi, this would be negative 3 pi over 2, and this would be negative 2 pi. And so what I'm looking at, if I connect those dots, is a nice smooth curve where that function repeats. You might already be thinking about domain and range, and if you are, that's a good thing, and if you're not, that's all right. We're about to do it together. All right, so here's some facts you need to know about the sine function. The domain, if you look at this function, see if I can get both of these in the same screen. The domain of this function is the set of all real numbers. Because you can find the value of sine for any angle measure, and it just continues and just keeps going in this predictable pattern. Okay, the range is really easy. The high point is 1 and the low point is negative 1. So all possible y values exist between negative 1 and 1. The sine is an odd function, and it is symmetric with respect to the origin, which you can see that if you reflect the sine curve over the origin, then you get the sine curve that's now on the negative side of the y-axis, to the left of the y-axis. The sine function is periodic, and its period is 2 pi. That means that it takes a stretch of like a length of 2 pi, an x interval of 2 pi, a horizontal interval of 2 pi, to be able to see one full sine curve. That was just bothering me that it was kind of jagged. Okay, which means that it repeats itself after that 2 pi, then it starts all over again. So the period is how long it takes to see one full curve, one full sine curve. The x-intercepts, well, there are 4 places. It says list 4. Okay, the x-intercepts are at 0, 0. You know what? Let's start from the far left. All 4 of those x-intercepts are negative 2 pi, negative pi, 0, pi, 2 pi. List 4. There are 5, and the y-intercept. I guess that would be the origin, right? 0, 0, both x and y-intercept. The maximum value is 1, and it occurs at the values negative 3 pi over 2 and pi over 2. The minimum value is negative 1, and that occurs Look back at our graph. That occurs at negative pi over 2 and 3 pi over 2. Okay. In the next video, we will talk about the cosine curve.